Hi, my name is Daniela Chavira, and this is my evidence on the micropropagation of Salvia leucantha. We were to solve the problem of infection of protozoa in different plant species. My team worked with Salvia leucantha, and the problem is that butterflies and pollinators consume this plant, and when the plant is infected with protozoa, this causes malformations and death on the butterflies and pollinators, especially on the butterflies, and specifically in monarch butterflies. So the plant, it belongs to the mint family. It's a bush, and it's a Mexican plant. So the origin is from the country. It's a local plant, and I mean, as I said before, it attracts pollinators. And the interesting thing about this is that it has second metabolites that have cytotoxic effects, like they could be used for cancer treatments, and they also produce like antibacterial, antiviral, anti-inflammatory compounds, who could be used as well for medicine or as a self-defense mechanism against the protozoa. Our solution to the challenge was mainly to find the quickest morphogenesis technique to micropropagate Salvia leucantha. So this way we could make a plant bank of sort, to be able to replace the sick plant or the infected plant with a new plant every time that we needed to. And as well, we wanted to play a little with the medium in which we grow the plant, so we could find the best media or the best combination of hormones to increase these compounds or these secondary metabolites and make the plant more resistant to protozoan infection. So for our experimental design, what we did was axillary bud morphogenesis, as I said before. So we took the axillary bud of the plant and we planted it in MS media. And we played a little bit with concentrations of phytoregulators or growth hormones. Then for the animal tissue culture we did cytotoxicity assessment on different cells. We did CACO2 and CHO cells. And basically what we did was take the extract we made from the plant, from the flowers, and we put it in the 96 well plate with the cells and a tint. The tint itself served to measure the metabolism of the cells. So then, if coloration appeared, it meant that cells were still alive. And we measured the absorbance of this plate to see the viability of cells after the addition of the extract we made. So this is basically our experimental design for the plant part, and we did 6 treatments in a control treatment, in which we added different concentrations of phytoregulators, as I said, and we did 6 replicas of each treatment, except for the control treatment, for which we did 3, and we maintained one of those treatments without an explant. For results of the plant culture, we had all samples contaminated, so we did not micropropagate anything. We didn't have any results to measure or to analyze via statistical analyze, and controls did not differentiate. But we had like the control that was left without an explant. That one was not shown. That one did not show contamination, so it tells us that contamination started from the moment we introduced an explant into the test tube. And we had no conclusive results, so we couldn't do anything, any statistical analysis. But does not disqualify Salvia leucantha for further analysis, but encourages further experimentation. As for the animal tissue culture, the experimental design also worked with different concentrations, but different concentrations of the extract added. The image above shows the composition of the wells, what we introduced into the wells, and then the table shows composition of the concentrations of extract. As for the design itself, the picture above shows the distribution of the wells of the extracts and concentrations of this one. For this, basically, what we could observe was that cytotoxicity was very low, like viability was still on the higher range. And according to the ISO 10993, it says that cytotoxicity is only it's considered a compound is not considered cytotoxic if it's under 20% of cytotoxicity, and ours was barely above 20%. So it can be considered as weak when it comes to cytotoxicity. So what we concluded is that basically it's not cytotoxic enough to do anything to the CACO2 cells or CHO cells. Either way, for discussion, we had fungal contamination twice because we repeated the plant tissue culture twice. Even if we changed the sterilization method, we had contamination again. So for further experimentation, we would recommend changing the sterilization method, the cleaning protocol, and just reviewing that overall. And maybe using a different part of the plant, since axillary buds tend to have fungal contamination that it's almost impossible to remove. And lastly, but not least, preclinical assays in cells should be maybe done in bacteria or protozoa or even fungi, so we could closely compare the effect on pathogens that the plant may have. But to address the original challenge, protozoa should definitely be used for these assays to assess the cytotoxicity of the extract or the secondary metabolites of the plant on this pathogen that is affecting the plant. As for my personal reflection, I would say our protocol proposal incorporates cutting edge biotechnological elements such as in vitro axillary budding for rapid micropropagation of a plant and the testing of the secondary metabolites for antiprotozoan and antibacterial properties. I think these techniques target two key market niches as well: ecological conservation by helping replace infected plants and support pollinators, and natural bioactive compounds addressing the demand for plant based antimicrobials. And as I said before, maybe even further assays could be used for investigating anti-carcinogenic properties, or maybe even the secondary metabolites of this plant could serve as medical therapies. And the added value lies in producing disease-free plants and exploring natural compounds in for health application, as I just said. However, challenges of this project may include potential contamination in tissue culture, viability in bioactive compounds, and ecological risk of introducing Salvia lucantha on a larger scale because it's a native plant and since it's a bush and it's pretty invasive, it could be dangerous for the ecosystem. And despite this, the project offers innovative solutions for conservation of pharmaceuticals with room for improvement in protocol optimization, of course, especially on the sterilization process, as I said. And this is everything on my part, and thank you.